everyone. Good afternoon. And hello, everyone who is joining us through Teams and online. Thank you very much for being here. Good afternoon from Pennsylvania. Hello, good afternoon, everyone. Thanks for joining us. My name is Nikisha Reyes-Grange. I'm Director of Marketing with Azure Data and AI. And I'm here to be your moderator today as we're going to talk about database capabilities that you need for your next awesome app. I am joined by an esteemed group of speakers. In the room with me is Andrew Liu, Principal Program Manager for with Azure Cosmos DB. And then we have dialing in here. Can we see them? Yes. We actually have CTOs from two wonderful, fast-growing companies, two digital native companies who have built their core offerings with on Azure and using Azure Cosmos DB. And I'm going to ask them to introduce themselves. I'm going to start with Kenny Myers from The Postage. Kenny, can you come off mute and introduce yourself?
Sure. So my name is Kenny. I'm the CTO of The Postage and been in technology startups for, I don't know, 20 years now. Would you like to know a little bit about The Postage, or what else would you like me to tell you about myself?
Yeah, well, if it's up to you. You can do this now, or we can do it in a little second. But since you're already speaking,
Okay.
Why don't you tell us a little bit about The Postage, and then we'll have Yoni do the same.
Okay, sounds good. So the Postage is an application or platform that is really all about something I'm sure everybody will be super excited to think about and talk about. It's death planning. So, so basically, it's a really difficult subject, but it's something that's very important. It's really making sure that you have all of your affairs in order, and everything is really collected in one place. So whether it is where's your will located, where are your all of your assets, what are your usernames and passwords for your accounts, so that loved ones can be able to have access to everything that they'll need to have access to, and also know all of your wishes. So what is it that you would like to have happen when you pass away? And so it came about really because our CEO, Emily Sizek, had a couple of grandparents pass away in 2018. And there was really two extremes. One who was really prepared for it, and so she had all of her plans completely laid out, and it was a relatively smooth process. And then the other end of the spectrum where they really weren't ready, and it just added a lot of additional stress on the family as they were trying to figure out what to do at the same time while they were grieving. And so that really is what inspired The Postage to be created. And then we started looking at, what is the best way for us to move forward in order to be able to help people at that really kind of difficult time in their lives where they really want to be grieving, but they also want to make sure that they're honoring their loved one as best they can. And that's really what the focus of the platform is. And it's something that we built relatively quickly. And we can talk a little bit more about that when we're ready to tell you about our architecture.
Awesome. Thanks, Kenny. And Yoni. Yoni is CTO with a great organization called Zero Friction, and he's calling us from Europe. Yoni, would you like to introduce yourself and tell us about Zero Friction?
Yeah, sure. Thanks. So Zero Friction is a product company which was founded in 2018 by myself and two other co-founders. So we focus with Zero Friction on providing a scalable, user-friendly software as a service, which is responsible for the meter-to-cash processes of thermal energy suppliers. Now, those who are unaware of what a thermal energy supplier is, well, thermal energy supplier is basically a utility provider that, instead of providing gas or electricity, is providing you with hot water, which is used to extract heat, which in turn is used to heat up your home or your building. So this means our platform is capable of all the back office processes, starting with receiving these energy readings, transforming them into energy usage, applying tariff structures, and in the end actually send out invoices or advances to the end users. They are then followed up by credit management processes like bank integrations or debt collection flows. Now, next to that, we also provide like a unique white labeled end user portal, which is also a SaaS, which allows end users to gain insights in their energy consumptions, view their bills, send over master data updates like move requests, change of tenancy, and so on. So, and about our operations. So now Zero Friction operates our software in the Benelux. We are servicing roughly, let's say 65, I think, district heating suppliers or building managers with our platform. The company grew immense the last year. So we started with 3 people. We're now with a family of 35 people, of which 14 are actually working on the product team. Now, maybe also a little bit of elaboration on why we've chosen Microsoft as our go-to technology partner. So that's an easy one. Since we, the founders, we were actually coming from the Microsoft ecosystem, Dynamics AX. So the choice was made swiftly to keep expanding our Microsoft and Azure knowledge and focus on a single cloud provider. So with Microsoft and Azure services, we actually keep trying to provide business value to our customers using these latest and greatest Azure technologies. And also worth mentioning is that we enrolled in the Microsoft for Founders program, which allowed us to expand on the back of many Azure engineers who assisted us with peer architecture reviews, Azure app consults, and of course, the highly appreciated credits program.
Fantastic, thank you. So the purpose of us getting together here and hearing from Yoni and Kenny is really to talk about like the enterprise grade features and capabilities that developers can take advantage of in order to build applications that are robust, that are scalable, cost effective, and also like manage their growth. So and part of this is actually based on a white paper that we recently published, and we'll throw up the URL where you can download it for free in a little bit. But I wanted to actually start with Kenny. Hello, Kenny. You had to expand pretty quickly, right? Your organization has, you've built this platform that has grown through partnerships with financial institutions and others. So you had to grow really quickly, and of course, you're trying to figure out how to do this seamlessly. Can you talk to us about that, that experience, and also how that worked on the database side with Azure Cosmos DB?
Yeah, definitely. So we were very fortunate. We started off as a B2C model, so we were offering our platform to customers directly, and that worked out pretty well. But we quickly found out that there were financial institutions that wanted to be able to, for many different purposes, mostly for estate planning and transitioning purposes, wanted to be able to offer this service to their customers. And in order to do that, we did have to make sure that all of our infrastructure was really up to speed. And we really knew that out of the gate that we were going to need that. And so that's the reason why we focused on Azure and making sure that we leveraged as many managed services as we could so that we could take advantage of all of the auto scaling capabilities, all of the just in built-in redundancies that we were going to need in order to be able to satisfy the needs of really an unknown number of people and very large organizations. And so that is something that we leveraged. Specific as to Cosmos DB, we started very early on what I think is something pretty unique and very useful. It ended up being very useful for us with just a couple of developers starting off. We were able to put together the whole system in really about 6 months. And we did that by really heavily leveraging the C# stack. So Blazor for our web application and Xamarin for our mobile application. So really everything completely C# based. So how does that relate to Cosmos DB? Great question. So what we ended up doing with Cosmos DB was to really tying into the logging middleware and being able to make sure that all of the transactions that whenever we logged anything, we were logging everything into Cosmos. And we also leveraged Cosmos DB for analytics tracking, making sure that we knew exactly what was going on at any point in time. Why did we do that? We did that because it's incredibly flexible and well suited for this purpose. So we were able to really take large payloads and be able to drop them off very easily into Cosmos DB and then query them to be able to see exactly what was going on. So if we were running into any issues, we could very quickly jump in and diagnose what the issue was and see as much as we wanted to include. So if we included the full stack trace, we could see exactly what was going on at the point in time that it occurred. And again, we could do all of that without having to worry about us being restricted by a structured logging system. So we found that to be incredibly helpful. And then from a large financial institution perspective, of course, the risk with that is there could be information that is being leaked inside of your logs that you don't want to have leaked. And we were able to, because of Cosmos and what we were doing there, it was very easy for us to just JSON ignore any of the properties that we didn't want to actually propagate into the database. And so we were able to do some relatively sophisticated logging with Cosmos DB and analytics tracking with it in a very secure and safe way. So, you know, we think that was a novel solution, and it certainly worked out very well for us.
Awesome, thank you, Kenny. Yoni, when you were architecting your solutions, you guys were kind of, you know, all cloud all the time, right? And part of what you were trying to do here is make sure that everything was integrating across the Azure platform, right? The full stack. Can you talk to us a little bit about the integrations that you've leveraged, especially with Azure Cosmos DB and other Azure services?
Yeah, sure. So if you take a look at our architecture, we use, of course, .NET Core as our backend technology and React as our front-end technology. But our architecture is comprised of a microservice landscape, which is running on top of Azure Service Fabric. Well, many Azure services are built on Service Fabric. Hence, we went for a proven technology when we started building our MVP beginning of 2019. Inter-service communication, that is done or achieved using the Azure Service Bus messaging and eventing. And then we use Cosmos DB as like the main data storage. Now, we also use Cosmos DB serverless for our end user portal, and then a few different Azure App Services for isolated processes like authorization or integration. And when you take a look at the Cosmos DB for the back office application, the billing application, what might be interesting as well is that when we started, it was still called Document DB in 2018. So you had like container level throughput, and then it shifted to database level provision throughput. Then you had the limit on 25 containers. So we did change our architecture in Cosmos DB on the way as well. And now we have like a very solid structure where we have each tenant in our multi-tenant application has its dedicated database spread over different Cosmos DB accounts. And then we have like different containers representing the business domain. So we are really a fan of domain-driven design. So our microservices, they involve a specific domain like billing or metering or communication. And they also represent different containers in the tenants' databases, where we then apply Autoscale throughput on database level, which makes our application very cost efficient, but also very scalable.
Thank you. So you've started touching on multi-tenant, and I'd love to understand if we can get a little bit deeper into scalability and performance. Did you have specific requirements or certain SLAs of your own that you were trying to hit?
Well, we didn't have like specific SLAs per se. We had like a few components which were required to be online all the time. And so one of these were, of course, the ingestion of the metering data or the energy readings we receive from all the different sensors. But that's about it. The billing application as is, we don't require a high uptime for that, although we achieve for no downtime at all. So past 5 years, we had not a single issue on service side where Cosmos DB was down, actually. And all our releases we do rolling. So that means that we actually try to aim to make everything backwards compatible. And that's really the power of Cosmos DB and the nature of Nosql as well, of course, is that like schema upgrades, we can really do them on the fly. We make sure that our schema changes, they are backwards compatible. If we do a new release, we make sure our code is backwards compatible, which means that basically you don't have things like schema patches you need to do in a regular SQL database, and you can just keep the system running all the time, which is really fantastic.
That's awesome. I love hearing about that uptime because we have a 5.9 SLA for high availability. So I like to know that we achieved 100 in your case. That's awesome. So Andrew, as the product expert here, I'd love to talk to you and hear about like some of the features and capabilities around scalability and elasticity. What can you tell us?
Sure. So scalability is an interesting problem. And then I'm going to go into elasticity as well. The challenge with scalability in databases is a little bit different from scalability in applications, right? In applications, if I am today on, let's say, one node, one computer, and I'm pegging the CPU, what do? I go and spin up another computer, and I hide it behind a VIP. And what I can do is I can continuously spin up more and more nodes, hide it behind a VIP, and I can continue to scale that traffic up and down. The challenge with databases is it's stateful. Well, if I have, let's say, the state for user A on machine 1 and the state of user 2, in order to scale that, I can't fit that on a single node. That's on machine 2. I now have to go and figure out the routing problem, right? Like if I query the wrong machine where the piece of data is not there, then of course, well, what is the point then? And so as you go and this is effectively the sharding problem in databases, right? And some of the easy problems and some of the harder problems in databases and sharding is easy problems at least setting up a shard structure such that you can route to the right machine. What becomes really difficult is the principle of elasticity. I want to be able to grow. I want to be able to shrink. And every time I grow and shrink, it's not just spin up a machine and hide it behind a VIP. It's, oh, I actually have to go and move the state and divide that state into more machines or collapse that state into fewer machines. And how fast you can do that also has a big determining factor on autoscale, right? Like many cloud services have autoscale, but if autoscale takes an hour to do this or a day to do this, if I have a surge in traffic, it's not acceptable to have this autoscale tomorrow. I need this right now to be able to avoid denying those requests. And so those are the key challenges that we try to solve really well in Cosmos DB. In terms of progression here, I would say we've solved the elastic growing and shrinking problem. And then some of the new capabilities that we find. So like there's a set of what does the service own and then what does the user own, right? The database doesn't know how to divide the state. It doesn't know the context of the application. And so what a user is expected is you have to define what's called a partition key. It's a placement hint for which attribute should I go and divide the data across. But once you've defined that, it's actually up to the database to grow and shrink the number of underlying nodes and do so in a predictable, routable manner based off of that partition key. And the other thing that where we've made, I think, a lot of interesting progression is, well, what if I get the partition key wrong? And so what happened historically in Cosmos DB is if I made a mistake, well, what it'll do is it'll elastically grow the number of shards or partitions underneath the hood and scale them uniformly. Some of the really new, cool new capabilities that we're releasing here at Build is actually to make that system a lot more forgiving. And so what we're doing is we're actually decoupling now the partitions such that they can auto scale independently as well as grow and shrink independently. So those are some of the cool new capabilities. But I would say like these are some of the technical challenges that what makes scalability and elasticity hard in data tier applications. And the overarching theme on Cosmos DB is, well, that's a hard problem. You shouldn't have to think about that. We want you spending more time building your application and ideally take on the burden of this elastically growing, shrinking number of shards. Like that is, it's a huge time sink that will take you away from your applications. Hopefully that's helpful.
Oh, sharding. Okay, so speaking of autoscale, so the way autoscale works with Azure Cosmos DB is basically you as the developer, you set your kind of max throughput for database operations, right? The system automatically sets a minimum, that's 10% of that max, and off you go, right? And because it's automatically scaling, you're also only getting billed for what you're using within that range. Now, Kenny and Yoni, I know you've both used Autoscale, and both for performance, but also for cost management. Can you talk to us a little bit about how you've been keeping your costs in line and just staying effective with your budgets?
Yeah, sure, I can start. So as a startup, as you can imagine, we're on a relatively tight budget as always, all the time. And so what we try to do is monitor those resources very closely. And again, we're using managed services across the board for everything. So that means whether it's app services or any part of Azure that we're leveraging, and all of them are set to Autoscale. So we're constantly kind of pulling them back and seeing how it functions, and then letting it just kind of Autoscale as need be. And we do have very spiky types of situations that come up because we'll get some press, and then that'll drive a large volume and a huge spike will hit. And so far we haven't had any issues at all. Everything is scaled up perfectly, and when the spike came back down, everything came down smoothly for us. And so we've had a lot of really great luck actually with scaling up and scaling back down. And again, that's all by design. The reason why we set it up inside of Azure, and the reason why we use Azure really for everything is for that purpose. And so it's working great for us, and it's allowed us to really save a lot of money because we don't have to run at a higher capacity just in case we get a spike. We can let the spike occur, and it'll scale up as needed. So it's working great for us.
Thanks. And Yoni, you've also used serverless, right? Could you talk to us about those experiences?
Yeah, sure. I've used both indeed. So we start with provision throughput, of course. So if you take a look at our application, we try to be like a very cost-effective entry-level application. There's quite some background noise. So basically, which means that our tenant base cost, so what is our minimum infrastructure cost for a tenant, needs to be as low as possible and needs to be related to the size of the tenant as well. So as a tenant grows, the infrastructure cost can grow with it as well. Of course, it should not be a one-to-one relationship. So we should still aim for the economy at scale. So when Autoscale back then, Autopilot was released, it was like, yeah, a no-brainer for us to start implementing it, of course. So first we started using Autopilot together with the reservations. And actually we've seen our consumption or Azure consumption charges related to Cosmos DB drop with about 40%, I think, just by implementing Autopilot and the reservations, as we are not over provisioning anymore. Now, Autopilot is a bit more expensive than manual scale if you need the constant performance. So I think there's like a 50% on top of the base price. But because of the spiky nature of our application, it's an event-driven application. We have like certain times in the day that the metering or the readings come into the platform. Yeah, Autopilot was like a natural fit for our application. So we did set like a baseline Autoscale on all our tenant databases. And then we did a performance benchmark. So we did like a test for 100,000 connections. So an energy supplier which serviced 100,000 connections with 100,000 devices in our platform. And that really impressed us. So we saw that we were able to generate like 100,000 invoices in under 3 hours, and that included the PDF generation. So Cosmos DB was really being pounded, scaling up very efficiently. And that also made us give us an indication on what size of scaling we needed in relation to the amount of connections. And as such, manually from time to time, we increase the rates for the big tenants. But we do feel it's not always necessary to keep track of tenants that did their Autopilot a lot, so there's still some room. Again. So still some room for improvements in that area. Now, when we take a look at the serverless part, so the serverless part that's used for the portal, so the end user portal, where the end users or the energy consumers can view their invoices, they can view their energy usage. Now, that's very spiky by nature. So when do people check their energy usage? Most of the time when they get a bill and they're not happy about the bill, they will take a look at the energy consumption and start to monitor their energy consumption in the coming days. So it's a very unpredictable type of load on the serverless application. So that made the serverless solution or serverless offering very cost efficient. So we are able to set like a very low baseline cost for our SaaS end user portal running on top of Cosmos DB serverless.
We actually had a question here that was directed to both of you, and the question was, from Steve Green, did you both start fresh with Azure Cosmos DB, or did you have historical data from other sources that you had to migrate or modernize in?
Yeah, so in our case, yeah, we started fresh, completely fresh. So we started building our MVP in 9 months, I think, running on top of Cosmos DB. Now we do have like a migration track for existing energy suppliers who choose our application, of course. But we have like a standardized framework for that, which is built within our application. So it's not that we had to port like coming from a SQL background to a NoSQL background. No, we really started from the bottom up using Cosmos DB as our go-to data storage service.
And Kenny, how about you? We also have a related question here, asking about your input data format, JSON, et cetera, for data ingest. Yeah,
so similarly, we started with Cosmos DB from the beginning, and that was obviously a design choice that we made. one thing that's slightly different for us is we do also have Azure SQL. So we have really both in our environment and used for different purposes. So we do have kind of a mixed mode, and I'm thankful that we haven't tried to move the Azure SQL stuff over to Cosmos DB and or vice versa. So but we did start off with very intentional designs in both cases, and everything is coded from scratch from that perspective. So no migration.
Okay. Any questions in the room? No. Okay. I'll check if there's any more questions in the chat here before I go on. So when I was muted, I was welcoming our international attendees and also doing a shout out to my fellow Canadians wherever you may be. So that's what you guys missed when we were muted. Hang on one sec, let's just look through. Andrew, there was a question in here. Timeline on when hierarchical partition keys will be in GA.
I have some good news. I believe it just GA'd today at Build. And for context, for those who haven't seen hierarchical partition keys, the challenge with partition keys is each partition key has a boundary of 10,000 RUs and 20 gigabytes of data, right? It's effectively a routing mechanism to a partition. In order to, I'll use an example. Imagine I'm building a multi-tenant application. What if I naturally want to route my request by the tenant? However, my tenant might grow beyond 20 gigabytes. Well, typically what you would do is you would create a composite key, right? You would overload the value where you have like value A, value B, value C. You might concatenate them and set that as the partition key. The challenge with that approach is now you have to know all three variables or all n variables to be able to route the request. And so what hierarchical partition keys is allows you to set up a hierarchy where as long as you know the prefix, right? If I know, let's say, most tenants are small, but if a tenant ever grows large, then subdivide it by, let's say, the user ID. It allows you to go, if I have a query where I have the tenant and user ID, I can route that. But if I only know the tenant, I don't need to route and do what's called a blind fan out, which is you talk to every data or every underlying partition or shard to go find that piece of data. Instead, by having the prefix, we can at least use that to locate and look drastically narrow instead of a blind fan out. Look at just the minimal number of partitions required to serve that request. And so that capability has just come out GA today.
Excellent. Okay, we've got a few other questions here. I'm sorry, we're going to jump around the topics here now. Sorry. Okay, there was a question about when can we expect an inbuilt GraphQL interface to roll out?
So we introduced a new capability called Azure Data API Builder, which allows you to do a native GraphQL interface over your choice of Cosmos DB, Postgres, SQL DB, and I believe MySQL. Today it's in preview. It's something that we're rapidly evolving, and honestly, do give it a spin. The team is very eagerly awaiting both feedback and watching the usage. And I mean, expect this to continue to receive investment over time as we take this to as a fully GA'd feature. Data API Builder. Got it. So I'll repeat the question. The question in the room is, I am using the Cosmos DB change feed. What I heard is there ability to filter on not all events, but a subset of events? Today, we don't have that capability just yet. We have made some new developments on the change feed. Specifically, what we released at Build is a preview for a new change feed mode, where we're calling it all versions and deletes. So I'll give you at least like an idea of where change feed is headed right now. Historically, what we did with the change feed is think of it as on Cosmos DB, we have something that looks like a log structured store, right? Whenever you write a set of records, like write operations 1, 2, 3, 4, 5, we're effectively persisting it on an underlying log with like a log sequence number 1, 2, 3, 4, 5. And the change feed is a way of just getting very efficient incremental reads from that. As you can imagine, if I'm doing a number of updates and deletes, that can result in some write amplification, where if I update a 1 KB record 5 times, there's 5 versions of it. Historically, we only tracked the latest version. The new capability for change feed that we did release at Build also today is if you have turned on the point-in-time recovery backup system. Cosmos DB actually maintains an archive of all the intermediate updates and deletes. It's the same mechanism we use for the point-in-time recovery backup resource system. And so you're able to get old updates and deletes. Change feed is top of mind. We haven't finished the filtering problem yet, but that is also next up on the change feed roadmap. So the question here is doing joins across document types. There's actually some really clever tricks on how to handle relational data. We try to avoid doing joins in Cosmos DB across documents because it is a cross product. And as you can imagine, if you have a highly scale out system, the machine-to-machine coordination for a cross product is actually really expensive. It's for the same reason why you typically only see these and scale out products only on the analytics side, is because the latency as well as the throughput, these are like very computationally expensive. So the latency tends to be high and the throughput tends to be fairly low. Rather than approach from that angle, what we really embraced is both the support of denormalized data structures, right, embedded objects, embedded arrays to represent relationships, as well as allowing heterogeneous schemas within the container. And so like a common thing that I've seen is I have two different entity types. They have a relationship. Even if I have normalized them within the container, rather than doing a join, what I can do is I can have common filter properties that I filter for. And if I combine them in the same container, the container is the scope of the query, that you can actually come back with different schema types in the same query. And then you can also do like a type in if you annotate the records themselves with a type property to then control what types come back on the read path. So there's like alternative techniques for doing so. And we actually encouraged this behavior as opposed to the cross product, mostly due to how expensive cross products are across shards. It's the exact same process that you go down even if you were using a relational database, right? Eventually, if you really care about the latency, you really care about the throughput, eventually you find that, hey, I can optimize this by avoiding the join and denormalizing the rows. In Cosmos DB, what we've done is we've just really embraced that denormalization. I should also mention that we do operate two stacks. In Cosmos DB, effectively, we have like a Nosql backend. This is all of the RU API models. We also have a distributed SQL capability, a backend. This is all the vCore APIs. And for vCore, we are experimenting and trying out full relational operators. You actually can run full ANSI SQL using Postgres head on Cosmos DB. I recommend checking that out if that does fit your use case. I also do encourage also thinking about the denormalizing just in terms of the performance trade-offs. It might end up with better perf characteristics overall.
Thanks. That leads us into, I'm going to join a couple questions. Speaking of joins, I'm going to join a couple questions together here. Okay, so there was a question about the design. So Kenny, what was the design criteria that led you to choose Azure Cosmos DB? And then there's another question around, relational versus distributed non-relational. Can you talk to us, about not only just choosing Azure Cosmos DB, but why did you choose a distributed non-relational database?
Sure. So as we kind of mentioned before, or I mentioned before, we do have both. So we have Azure SQL as well as Cosmos DB, and so for us, really the choice was around what did we need in each specific situation. So we had some things where we didn't want to be constrained by having a predefined schema. And so that's the reason why we basically chose to go with Cosmos DB for those types of things. And there's other scenarios where we were very comfortable with the predefined schema, and we wanted to have that very normalized data structure. And so in those cases, we did use Azure SQL. And so that's kind of one of the criteria. The second one was around security, and we had a design in mind very early on to really distribute the data in order to make it even more secure. And Cosmos DB and things like that make that much better and easier to do as well in a similar way to Yoni was describing as well. So I think it really depends upon the use case. I think that I could make an argument either way for almost every type of technology that we're working with. But for us, that's kind of why we did it. We really focused more on Cosmos DB for the things that we wanted to really isolate and make sure that we had unique containers for users and unique containers for very specific other aspects of the application, but with the flexibility to put really anything inside them that we needed to that was related to that particular entity. And so that's kind of, hopefully that makes sense, but that's the reason why we really went with Cosmos DB for a good portion of the security aspects of the application, because when you're storing information like wills and usernames and passwords and things like that people definitely want to have access to, the more distributed it can be, the more isolated any, if there is by some crazy instance some sort of an attack, it isolates the data that could be retrieved from the attack to the very smallest piece possible. And so that's another part of the criteria that we used for kind of distributing the data around inside of our system.
Yoni, how about you? Are you using multiple databases? And if so, how are you choosing which to use when?
Yeah, so we do indeed use Azure SQL as well. So Azure SQL is the database we use to manage our authorization layer. So the concept of tenants and all the different roles and responsibilities and so on, they live in a separate SQL database because that's a schema that really doesn't change much over time. But as opposed to the Cosmos DB, I think we did already maybe 1,200 schema manipulations on 4 years or something. So it changes a lot. And that's really the benefit. It's not specific Cosmos DB though, it's the NoSQL part, I think. And maybe to pick on Andrew's story a little bit as well, is the fact that it does require you to think differently. If you come from a relational background, you really need to change your mind and not think in concepts of joins, but you actually need to think, okay, what kind of data does this process need, and how can I efficiently gather that data in one JSON document? So also, like if you have like list pages in the application and you need to filter on certain properties like a customer name, for example, or a customer number, something very common. What we do, for example, is we make sure that some certain base fields or base properties of a customer is actually shared across those entities and is stored in Cosmos DB and is also kept up to date with eventual consistency. When a customer name changes, events are thrown, and these documents are updated in an async way. But it allows you to have like very fast user interface, very fast processes. That's why also the performance benchmark really showed us, look, the application is really scalable. Now, if you then take a look at Cosmos DB specifically, as Cosmos DB is a managed service. Now, what is most valuable for a startup company? Two things, I think. They are actually the same, which is time and resources, or all combined, money. So when you choose for a platform like Cosmos DB, you don't need to think about indexing, or at least in the beginning, you don't really need to pay much attention to it, to indexing. There's no such thing as backups you need to maintain, logs you need to ship. The DBA activities really are drastically reduced. And actually, by using then Cosmos DB, we were actually allowed to, or able to, create our MVP in like 9 months or something. So we built our entire meter to billing MVP in 9 months with just 2 people. And that wouldn't be possible without Cosmos DB, even though we were not familiar with Cosmos DB, nor familiar with NoSQL databases. So I'm really a fan here.
Thank you. We're also fans of yours. Okay, so speaking about the whole NoSQL versus relational, the issue that tears apart our community every time we talk about this, we now actually do support relational data within Azure Cosmos DB, right? Azure Cosmos DB for Postgres, but it's distributed, kind of NoSQL. They've got a couple questions I'm going to join together here. Can you talk to us about the benefits of using distributed database for relational data?
Oh, sure. So two things. One is more like a high level level setting. At a high level, I actually find that most solutions, if you look at as your architecture grows larger and you scale to a larger and larger user base, typically what happens is you break things down into microservices so that you can decouple and independently scale them. And then rather than thinking about a database as like a hammer, not everything's a nail. You actually end up doing what's polyglot. It's called polyglot persistence, where you actually end up using different databases for different microservices. And from what I'm hearing, this is what both Yoni and Kenny have also embraced in their architectures. Specifically for Cosmos DB, and if I compare that to, let's say, Azure SQL DB, the main thing that you really get is distributed databases. It's the sharding and the replication capabilities. Sharding's really hard, replication's really hard. And then also things like manageability over that, right? Growing, shrinking, the autoscale capabilities, as well as schema management. If you are told that, hey, my application's moving quickly, I now need to update the schema. When I do alter tables, create index across, let's say, 10 shards replicated 3 ways, and you're told there's no maintenance period. You must do this online. Those are the type of challenges that kept us awake at night. And as Microsoft made its own journey from box software to cloud a decade ago, as the data volumes grew, those are the challenges we needed to solve also for our own cloud services. And so, like, in a nutshell, I would say if you have requirements around sharding, that's typically a scale problem. Or you have requirements around high availability, that's a replication problem. This is where Cosmos DB tends to be a really good fit for that microservice. In contrast, I also think there's a lot of merits with Azure SQL DB. It's incredibly feature-rich, right? If I want to scale up database for, let's say, a line of business application, honestly, there's so many more features in that query surface area than there is in Cosmos DB, that those are also usually signs that this might be actually a very good fit for SQL. And so I would evaluate microservice by microservice to go and figure out what are the distinct requirements for that microservice, and then choose which tool solves that problem best.
Thank you. Before we get played off, because I feel like we are at time here, just wanted to share that you can download the white paper that a lot of this is delved into in more detail at aka.ms/scale-whitepaper. I'd also encourage you to please feel free to get in touch with any of us. You can find us on LinkedIn. I think you got all of our names previously. And thank you very much to our panel, Kenny, Yoni, really appreciate it. Thank you for joining us. Thank you very much, and thank you for everyone who is here.
Thank you.
Thank you.